Okay, in this lesson we're going to look at a construct that's called an array. That's A-R-R-A-Y. Okay, so that's his name. I'll just write that down, A-R-R-A-Y. Now, that's not a special keyword or anything, that's just the name of the type of thing that it is. So we're not going to give it that name when we do. Basically what an array is used for, we see here where we've an integer variable called I, and that holds a single integer. But what happens if we want to have something that would hold, let's say, 10 integers or 100 integers or 5,000 integers? How do we give that all one name? So it's a little bit like I here being the name of an individual bungalow somewhere or a house somewhere, and we want to give a whole name to a street. So what I'm going to, I don't like using the word array, because you may start to believe that that's what we should use every time. So I'm just going to call it a set for the moment, as in a set of numbers, and I'm going to decide that we're going to put 10 numbers in this. So this is like a set of 10 integers, or you could think of it as this is the name of a street with 10 houses in it, where each one of the houses is going to hold one number. Now, unlike a street, where the house numbers would start at 1 and go up until 10, in C we start at 0 and we would go up until 1 less than the number that's in the thing, so we go from 0 up to 9 when we're dealing with the index to each value, or the house number if you want to think of it as a street of houses. So what we can do firstly is we can, there are a number of ways of initializing this. Let's say I want to put my 10 numbers in. One of the ways I can do it is I can put them in right here and now. So I'm going to fill it with 10 numbers, and I'm just picking these numbers at random. How many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you can see there I've used the braces in the initialization. That's how we would do the initialization of these. So that's a set of 10 integers. So each one of these is an integer, and this is the integer at index 0. This is the integer at index 1. This is the integer at index 2, and so on. This is the integer at index 9. Okay. Now, so let's say I wanted to print out one of these. Say at index 3 is set D. I would write the name of the array, in other words the name of the street, and then put the number 3 in there, and use the square brackets again for that, same as we used up here. And so what this will do is it'll print out one of the numbers. Now, the question I'm going to ask you before I run it, so think in your own head, which number is it going to print out? Is it going to print out the number 3? Is it going to print out the third one in, which is the 6? Or is it going to print out the number 8, because it starts at 0, so 0, 1, 2, 3. Okay. Now hopefully you picked the number 8 for that. We'll give it a go. And we see the integer at index 3 is 8. Now, what we can also do is we can use a loop, like we saw previously, with for loops and while loops, to print out all of the sets, all of the information that's in there. So I can use a for loop. Let's say I want to print out all 10 numbers, so I say I, this is why I had the I up above, I is assigned 0, I, the J, I smaller than 10, and we're going to go up in values of 1. Okay. And what I'm going to do here is I'm going to say the integer at index, and I'm going to have to put in a %d for this as well. So what I'm going to do for the first percentee is I'm going to put in the value I, and for the next one I'm going to put in the I'm going to put in set, and I'm going to leave it at 3 for the moment, just till you see what happens in that particular case. It's not going to do what I want it to do. So what occurs in this case is that we say the integer at index, and I put in the value of I there, is this number here. Okay. Now remember that the for loop is set up so that it starts at 0 and goes until 9. Okay, it won't go to the 10th place because that will not be smaller than 10 anymore. So we expect this printf then to run 10 times, and in each case the value of I goes up by 1 each time. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And it's going to print out that value. Now remember that the I is like the number of the house, and as we come to each house it has a different number it has a different value in there. The first house is 12, the next house is 4, the next house is 6, and so on. So don't mix up these numbers here, which is the number that's contained within it, with the index to which one we're dealing with. Okay, so because it can be very easy to do that. Now if I run it there the way I have it, and actually what I'm going to do is I'm just going to put a little slash n at the end of this so that it goes on to a new line each time, otherwise it's very hard to read. We can see that the integer at index 0 is 8, the integer at index 1 is 8, the integer at index 2 is 8, and so on, which is clearly wrong there, because it should be saying 12, 4, 6, 8, and so on. And what's occurred is that in each case we have set and we've put in 3. Okay, so it prints out the element at number 3 each time. Instead, what I want to do is I want to have something that's going to change, because this printf is going to happen 10 times. So what better thing to use than to use the value of I in there? And that means that in the first case we're going to go to set 0, and in the next case we're going to go to set 1, and the next case to set 2, and the next case to set 3. But obviously I can't write in each of those numbers, so I use I there, because I know that I is going to change in value each time we go around the loop, and more than that, it's going to match up with the index that I've mentioned here. So take a run at that, and we see now that the integer at index 0 is 12, the integer at index 1 is 4, blah blah blah, all the way up to the integer at index 9 is 3. So what happens is the for loop runs for the first time, and it gets the I value gets initialized to 0. We check if I is smaller than 10, which it is, which means the loop is going to run. And we run this printf with I being a value of 0, so the 0 gets printed out here, and I goes in here, so it's the same as saying set 0. Set 0 is this one here, which is the first number in the array, and it prints out the 12, so it's the overall thing here goes into the percentee here and becomes the 12. So it'll say the integer at index 0 is 12. Then finishes the for loop and comes back up here again. We don't reinitialize, that only happens the first time, but we increment the value. In other words, this thing gets put up by 1. So I becomes a value now not of 0 anymore, but a value of 1. And we check is 1 smaller than 10. It certainly is. So we run our loop again, or run our printf here again, and so value of I, which is 1, goes in here. So it'll say the integer at index 1 is, and then this percentee gets filled with this number here, which is going to be set I, which I is a value of 1. So it's going to say set 1. It's going to take that number there, which is 4, and print it out there. And that will continue to happen each time the I value goes up by 1. We test to see is I still smaller than 10, and if it is, we print out whatever's required here. And so we see them come out. Now, what we can do is we can decide that we're going to hop up. In other words, we're only going to do every second house. Let's say I is assigned I plus 2 this time. And we'll see what happens. So the integer at index 0 is 12, that's certainly correct. The integer at index 2 is 6, so it's jumped the 4 in the middle. Integer at index 4, so 0, 1, 2, 3, 4 is 9, and that's correct, and so on. It goes up to 8. It doesn't do 10 because 10 is not smaller than 10. Okay. Now, I'm going to put that back to its plus plus, and what I'm going to do is I'm going to show you that individually we can change an individual value within the array to a certain number. So let's say I want to change that 123, I want to change that to a 17, for example. Well, we look at the indexes, that's 0, 1, 2, 3, 4, 5. So what I can say is set 5 is assigned 17. And what that will do is it'll overwrite the 123 with the number 17. Just to prove that, we're going to run the program, and this for loop here is going to print those out for me. And it's telling me I've got a problem. And the problem is that I've left an equals here by accident. So, and we can see 12, 4, 6, 8, 9, and then the 17 replaces the 123 that we had up there. So individually we can change one of these values if we want. Let's try another for loop here. What I'm going to do is I'm going to use a for loop to initialize my value. So I'm going to get rid of these ones for a moment. So I'm going to write a for loop. And what I can do is I can reuse the I from before, because it will get reinitialized when it goes into this for loop anyway. Now, this can be useful if I want to put something into the array that follows the indexing of I in some way. So let's say, for instance, that I wanted to put in the numbers 0, 10, 20, 30, 40, 50, 60, 70, 80, and 90. Handy way of doing that is basically say I multiply by 10. And obviously, which value does it go into in set? Well, it has to go into all of them, so we need something that's going to change each time the loop comes around. So rather than putting in 0 for the first one or putting in 1, what we do is we put in the value, the index I, so that each time when I is 0, it'll say set I equals 0 multiplied by 10, which will be 0. Next time round, I will be a value of 1, so it'll say set 1, or the index 1 of the array will be 1 multiplied by 10, so 10 will go in there, and that will continue all the way up. Let's give it a go. Again, this for loop down here is going to print it for us. So we see 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay. That's fine if we want to do something very uniform like that, but what if we didn't want to do that? Well, you could have a situation whereby you asked the user in each case. Let's have a look at that. A number. I'll say an integer just to be specific. GER. I don't need to put anything in there, and then do a scanf, CANF, and we're taking in integers, comma, and I say ampersand set I. Okay, so I can get rid of this. So in each case, as we go around, it'll put the next integer that comes in into the next value in the array. So as I value goes up, in the first case it'll put it into element 0 or index 0, in the next one into index 1, index 2, index 3, and so on all the way up to index 9. So let's give that a go. Syntax error before scanf. I've gone and forgotten my semicolon, a regular occurrence. Now please enter an integer. I should have said an integer, but you'll forgive my my grammar. So there's a 2, we'll put in a 4, we'll put in a 3, 6, 76, 12, 54, 789, 32, 12, and at that point then it goes and prints out the information. So it prints out the 2, 4, 3, 6, 76, 12, 54, 789, 32, and 12. So there's another useful way of filling up the array if you have the time or the reasoning to enter the value. So it would be very good, for example, if you were doing a set of exam results or something for a class, or maybe a set of accounts for somebody as to what how much money they owed or whatever, that you could set up an array and you could start spinning through that and entering each one of them in turn, and you could then print them all out in a row. There are also mechanisms to take this information in from a file, so maybe some database file or something like that may actually hold this information. We may have some reason to want to take it into the computer and hold it all in an array while we do something on it. A typical example of that might be in digital signal processing. If we were dealing with a digital signal, it's effectively made up of an array of numbers, and we may want to do some operation on it. So what I'm going to do is I'm going to make a very simple signal here, and I'm just going to make it up out of random numbers. So this is an important one to see, where there is a function called rand, and what I can do is I can fill up my set, or my array of numbers, with random numbers. So each time it comes to this, so for index 0, the first element in the array, it'll call the random function and it'll return a random number. And so that'll happen for all 10 of them. Let's give that a go and see what happens. Okay, so we can see the random numbers that have gone in there: 41, 18,467, 6,334, and so on. Some very large numbers there: 29,358. Now, the thing is that the random number generator will return integers in the range from 0 up to 65,535, which is a 16-bit number in effect, right? Now, let's say I want my random numbers only to be limited to a certain set of numbers. Let's say I don't want any of them to be larger than 20, so 0 to 19 is all I want in it. I can use this guy here, which you should by now recognize as the modulus operator. I use it in an awful lot of the programs that I do. What the modulus operator does is it gives us the remainder. So whatever number rand comes out with, let's say it's 5,678, what will occur is that number will be divided by 20. And if we divide that by 20, let's take a quick look on our I know the answer is going to be 18, but I'll just show you how that comes about. So we'll say 5, 6, 7, 8 divided by 20. So it goes in 283 times and 9 left over, or sorry, 0.9. So 200, it goes in cleanly 283 times. Let's have a look at that. 283 multiplied by 20. That gives me the number 5660. Okay. So if I take 5, 6, 7, 8 and subtract 5660 from it, that is how much will be left over, 18. And that is definitely a number between 0 and 19 inclusive, or 0 and 20 not including the 20. And so that is the number that will go in. So in every case, no matter what we do, the random number generator will generate a random number, which may be quite large, but we will divide that by 20 and only take the remainder. And of course the remainder can't be 20 or bigger, because otherwise it would have divided in cleanly one more time. That only works with integers, of course, so do remember that the modulus operator is only something that you use with integers. So let's give that a whirl and see if that has indeed happened. And you can see I've loads of random numbers there: 1, 7, 14, 0, 9, 4, 8, 18. 18 happened twice there, 2 and 4. And so therefore they will be randomly generated. Now we see we've got two 18s in a row. There's nothing wrong with that. It's still a random sequence there. One thing to notice with the random number generator is that if I run this program again, I get the exact same set of numbers again. So while it's statistically random, when I use the rand keyword like that, it repeats itself every time I run the program. That's very important, because if I'm trying to figure out how to write a program and the numbers that it's generating are different every time, that makes it very hard to debug what problems we might have. So the rand will actually generate the same set of random numbers each time. If we want a different set, we can call the srand function just once and put some number into it, or you can find another mechanism, maybe putting the time from the computer into it or something like that, and you can see we've come up with a different set of numbers there. And if I use the same srand there, I get the same set of numbers each time. If I change the number in here, if I prime it with a different number, I get a different set of numbers coming out. Okay, so that's That's both arrays and also using the random number generator, which is an important one which you may need to use from time to time to do things. Okay, so that's the end of the one on arrays, but arrays will be coming up again and again throughout the rest of the programming that we do, so it'll probably show up in more recordings from now on.